Okay, in this video we're going to evaluate radical expressions. So, for example, if I have the square root of 24, I can simplify that a bit. So the first thing we're going to do, as we've done with the rational expressions and things like that in the past, is we're going to factor things down as far as we possibly can. Factoring makes us look at smaller values, and looking at those factors is easier to work with than these bigger numbers. So 24, it's not that big, but we're going to rewrite it as 2 times 2 times 2 times 3. Right? We factor it down into its prime factors, and we see that we've got a pair of 2's here. We've got 3 of them actually, but because it's under the square root, and we think of square roots as half of all of the things in here, right? I could think of this as 2 to the 1/2 times 2 to the 1/2 times 2 to the 1/2 times 3 to the 1/2. Because it's under the square root, we talked about exponents being, the radicals being fractional exponents. Well, these two guys together form a full 2. So I've got a 2, and then I've got a 2 to the 1/2, and I've got a 3 to the 1/2. Well, I'm going to put these back under. These are fractional exponents, and I can't combine them with anything else to make a whole number exponent. So we're going to put those guys back under a radical, and I'm going to write this as 2 times the square root of 2 times 3, which we'll write as 2 times the square root of 6. So this square root of 24 simplifies as 2 times the square root of 6. Okay, so that was kind of a basic one for us. Let's do something that has some algebra in it. Okay, before I do that though, right, let's look at the square root of x squared. There is no condition on x right now. It could be a positive number, or it could be a negative number, it could be 0. But when you square it, which happens first because it's on the inside things usually happen first, it becomes positive, and then I can take the square root of any positive number, right? We can't take the square roots of negatives because there's no number when you multiply it by itself. Like if you take a positive number and you multiply it by itself, it stays positive. If you take a negative number and you multiply it by itself, it stays negative. So you can't take a square root of a negative because there's no number when you multiply it by itself that becomes negative. Right. We eventually get imaginary numbers, but right now we don't have any type of number that we can multiply by itself and get something that's negative. So because there's no restriction on what x is, this square root undoes the squaring, right? I want half of a factor of something that gives me x squared. Well, it would just be an x. But I can't take the square roots of negatives, and square roots always give me positive numbers out, so I'm going to rewrite this as the absolute value of x. Similar things happen with the fourth root, right? If I have x to the fourth and I take the fourth root, I'm going to get the absolute value of x again. With a cube root, say I have the cube root of x cubed. This just actually gives me x back, right? Because let's say, for example, if I take -2 and I cube it, I get -8. And the cube root of -8 is still -2, right? The odd exponents, those negative signs stick around, and you can find something, right? If you want a negative cube, you start with a negative value and you cube it, because those 3 negative signs stick around and stay as a negative sign. So odd roots, we don't need absolute values. Even roots, sometimes we need absolute values. And I say sometimes because I'll give you an example where we don't need one here. So we just really have to think about when we're doing even roots. Sometimes okay, so let's see. If I take the square root of x to the fourth, right? I would like to say that this is the absolute value of x squared. But x squared is already always positive, so I can just write this as x squared. Alright, the square root of x to the sixth. Well, I'd like to say that that's x cubed, in absolute value, and here I do need the absolute values, right? I need these. Since this cube, it could still end up being negative. If x was negative in the first place, it could still be negative. But the square root, the output of a square root function, that's always bigger than 0, so I need the absolute values there. Okay, so those absolute values can kind of be tricky a little bit, but you only really have to worry about them when you're dealing with even roots, and then you just have to think, okay, could this number that I have in the absolute values be positive or negative? Well, if it could be either one, I need them. If it's always going to be positive, like x squared was always going to be positive here, we don't need them. Alright, let's see another example where I actually have some combination of numbers and variables inside this. So let's look at, say, the cube root of 27 x cubed y to the 6th. Okay, so I can break this up. I can take the cube root of 27 times the cube root of x cubed times the cube root of y to the 6th, and I get 3 times x times y squared. Okay, I want to form these into triples, and I've got 6 things here, so when I form them into triples, there's two groups of 3 things under the cube root, so I get 2 full y's left over. Maybe I should write that out more explicitly. Let's do another one. Let's do say the fourth root of let's go 32 x to the 5th y to the 8th. Okay, I'm going to write this all out, and we're going to see what happens. So I've got 2 times 2 times 2 times 2 times 2, that's 32. And this is still under the fourth root. And I've got x times x times x times x times x, and I've got y times 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 y. Okay, that's a lot of stuff to write out, and we don't always have to do that. But the fourth root, I just want to use it for like illustration here. The fourth root means 4 of these together. Each one of these is worth a fourth of a 2, so 4 of them together get to come outside as a full 2. 4 of these x's together, they get to go outside as a full x. 4 of these y's together, I've got 2 sets of 4 y's, so I get to bring both of those out, and I get y times y on the outside. And I still have some stuff left over on the inside. So I have a 2, I have an x, I have a y squared on the outside, and on the inside of this fourth root, what's left over? I've already used up that, I've used up that, I've used up that, and I used up that, but I still have a 2 and I still have an x left over. So the fourth root of 32x to the 5th y to the 8th is 2 times x times y squared, because those are the groups of 4 that I could make. And then I still had a 2 left over inside, and I still had an x left over inside, so those stay under the fourth root there. Okay, let's do one with a little bit more algebra again. Let's take the square root of, say, x squared minus 4x plus 4. Okay, I've got a square root and I've got an x squared in there, but remember, whenever these things are working, I've got hidden parentheses around. So I'm not just taking the square root of x, I'm not taking the square root of 4, I'm not taking the square root of that stuff, right? These things are an entire entity by themselves under the square root. So what we can do, though, is we can factor. And if you recall, this factors as x minus 2 squared. So I've got the square root of this thing squared. And if you remember above, when I took the square root of something squared, I got the absolute value of that one thing, right? So this is the absolute value of x minus 2. We factored it. I can't take the square roots of the individual pieces because they have to be treated as an entire entity under that square root, right? Why is that different from the multiplication? Well, square roots, remember, we're thinking of as exponents, and exponents on a multiplication can kind of be distributed, but we can't distribute like an exponent on a sum or a difference, right? We have to FOIL things out, and there's always that middle term that we have to deal with. Well, it's the same thing with these radicals. If you think of the radical as an exponent, there'd be middle terms because I've got these subtractions here when you sort of FOIL that exponent out, that radical out. That's kind of a way to think about that. Okay, so that was some evaluation of radicals. We'll do a little bit more, and we'll deal with some more negative stuff and positive stuff, and then we'll try and get some graphs in the next video.